Run-length encoding is one of the simplest compression techniques that replaces consecutive repeating characters with a count and single character. While not the most efficient for complex data, it's the foundation building block for many advanced compression algorithms. This web demo brings ALE to life through a basic interface where you can generate random text patterns, watch them compress, and then decompress back to the original. The HTML structure creates a dark-themed grid with 3 action buttons: generate, compress, decompress, paired with corresponding text display areas. The CSS uses viewport units for responsive sizing and CSS grid for precise layout control, with green monospace text. The interface uses a straightforward grid layout, where each button position corresponds to its related text display area. The Generate button affects the top text panel, compress the middle, and decompress the bottom. This clear spatial relationship makes the workflow intuitive without unnecessary visual complexity. At the heart of the program is the generation function. It dynamically populates the text area with procedurally generated words. 70% chance to repeat characters. Uses word length weight distribution. Compares scroll height versus client height to prevent overflow. Recursive request animation frame calls enable smooth rendering. Word length function returns word length following a custom probability curve. The function uses 2 hard-coded arrays that work together like a probability ruler. The first array contains all possible word lengths. The second array acts as a cumulative probability thresholds. Each number represents the maximum chance for all lengths up to that point. When you call mathRandom, it generates a number between 0 and 1. The findIndex then scans the probability array to find where this random number fits. The 2 arrays are essentially pre-calculated probability buckets that convert random number into weight-length choices. These methods give precise control over word length distribution without complex math. It's just a clever way to map random numbers to desired probabilities using simple array lookups. The pipe 0 bit converts decimal numbers to integers by chopping off everything after the decimal point. Update grid content function targets specific grid areas for content injection. Select a strategy attribute-based CSS selector. Compression engine. Stage 1 tokenization. Group 1 captures alphabetic sequences. Group 2 captures whitespace buffers. Stage 2 run encoding. Captures lead character. Back reference \1 matches subsequent identical characters. Replacement logic runs greater than 1 character, length plus character. Single characters remain unmodified. Decompression engine. Number letter pairs. Captures run length. Captures character. White spaces passes through unchanged. I specifically choose text over images for this demo because it perfectly showcases regex pattern matching. You can literally match AAA. You can literally watch AAA become 3A and back again. While While RLE works better on images with large uniform areas, text compression makes the algorithm mechanics transparent. This implementation reveals how even basic compression rests on pattern recognition, and how those principles scale up to power modern formats like PNG and zip. The link to the file location is in the description. Let's scan the implementation. That's all from my side. Be well.